So in the next series of videos, we're going to go through the Unit 9 practice test. In this video, we're going to get the first two learning objectives, which have to deal with differential equations. So this first one, we're just trying to model situations with differential equations. So we're going to have some type of word problem and kind of use those words in order to create a differential equation. So again, you can pause the video and read through the whole thing. I'm just going to kind of tell you the most important bits. All right, so they realize that S and T are kind of changing together. And after taking measurements, determines the rate of change of S with respect to T is inversely proportional to the natural logarithm of the quantity of T. All right, so that's a lot of words, but that's really the only part you really care about in this whole paragraph. All right, so if S is changing with respect to T, that tells me that this is my derivative. All right, the change in S, the little d, means the change in X. The division bar is with respect to, and then the change in T. All right, so that's the left-hand side. All right, it's inversely proportional to the natural logarithm of the quantity of T. So there's going to be a natural log of the quantity T. Inversely proportional means there's going to be a fraction bar, and we're going to put the natural log of T on the bottom. And proportional means it's not exactly a one-to-one thing, but there's some constant k that might affect it. So we're going to use that k to represent that it's proportional, not exactly the same. All right, so this is our equation, and we see which one matches, and it is C. All right, so again, just going through the kind of important parts. Change of S with respect to T tells me that left-hand side. Inversely proportional tells me the fraction bar. And obviously the natural log of T is the natural log of T. So this one's going to be similar at the start. Again, there's a lot of information, but you can pause the video and kind of read through it. I'll tell you the important bits. All right, so the important bit is the population increases with respect to, you can see respect to is one of the important things, with respect to time, at a rate that is directly proportional to the population. All right, so that tells me that the population with respect to time is directly proportional to the population. And they say on August 15th, the ideal conditions start. And then on August 20th, which is 5 days later, there's 10 million insects, and the population is increasing at a rate of 2 million. All right, so what is that going to tell me in terms of my thing? The rate that something is increasing is the derivative, so that's going to be 2. And then the population is 10, so that's going to be B. And if I divide, I get that 2 over 10 equals K. Of course, 2 over 10 is 1 over 5. So it's telling me that the K value is 1 over 5, so my final answer is dP over dt equals 1/5 P, all right, which is D. All right, this one looks related to something we'll do later when our differential equation looks like a constant times P. All right, you would find the solution for that, but because they're giving you the rate here, that's telling you what that derivative is. You actually don't have to solve this differential equation, you just plug it into the equation you created. Here's another word problem. Again, you can kind of read through it, and I'll tell you the important part. So pressure P is changing based on the volume. All right, the rate of change of the volume with respect to the pressure is proportional to the reciprocal of the square of the pressure. So that one sentence is kind of going to lead us to our answer. So rate of change of the volume with respect to pressure. All right, so volume should go on the top and pressure go on the bottom, is proportional. So again, that just tell me proportional means there's some constant K that's going to be affected. And then the reciprocal, so reciprocal is a fraction of the square of the pressure. So again, just putting those pieces together, the first half of the sentence gives me the left-hand side, and the second half is going to give me the right-hand side. And we figure out which one of those matches. It's dV dP. There. And for the free response, all right, just creating your own differential equation. Just remember, your differential equation is any type of equation that involves a derivative. So there's an infinite number of answers here, but you could do something like y double prime plus 2y prime equals 7. All right, that's an equation that has derivatives in it. You could do dy dx equals 7x plus y. That's an equation that has a derivative in it. You do dy dx minus y plus 3 equals x. Again, as long as there's a derivative, whether it's in this Leibniz notation with the dy dx or the Newton notation with the prime, either one, as long as your equation has a derivative in it, then it's a differential equation. All right, our next topic is about verifying solutions. So in a multiple choice question, it's not really about just verifying. There's always going to be some little extra trick you have to do because they can't just like have it be yes or no for the answer. All right, so there's a lot of these ones where you have to find the value of k that does satisfy the equation. All right, so for this one, we have our y given to us, and we have this differential equation. And if you look in the differential equation, you'll see that there's y double prime. So the first thing you do is figure out what is y double prime. All right, for us, y prime, I've had to do the chain rule. K is a constant, so it's just going to stay there. And derivative of e to the negative 2x is e to the negative 2x with an extra negative 2 because of the chain rule. All right, plus the derivative of, all right, this 4 is going to stay there. Derivative of cosine is negative sine, 3x. And then we have to, because of the chain rule with that 3 on the inside, we got to multiply by 3. So let me just write that a little bit simpler. Now we take the derivative of that again. So again, the chain rule, the negative 2k is going to stay. That's going to turn into positive 4k e to the negative 2x. All right, the negative 12 is going to stay. I take the derivative of sine is cosine. And it's going to give me negative 36 cosine of 3x. Again, the 36 is coming from the fact that there's this 3 in the parentheses. So I take its derivative and multiply by another 3. All right, so that is our second derivative. And our equation says I take my second derivative. I'm going to add 9 times the original function. And I want that to end up being equal to 26 e to the negative 2x. All right, first I want to simplify this left-hand side as much as possible. So when I distribute, I'm going to run out of room. So it's just kind of look, there's going to be 4k of these e to the negative 2x's and another 9k of them. So together that's going to give me 13k e to the negative 2x. I'm going to have negative 36 of these cosines. 9 times 4 is positive 36, so these are actually going to cancel out, and that just gives me this expression. All right, I want this here to be equal to the right-hand side of this equation, so I know it's a solution. And how do I do that? Well, I have 13k of the e's. I can even like cancel out these e's to make it even simpler. So if 13k equals 26, then k has to be 2. All right, so just taking your derivatives correctly, just remember k is a constant, so it just stays when you take these derivatives. And then just figuring out what that k value would be at the end. All right, there is a question where they're just going to ask you straight up, like, do these solve this differential equation? They're going to give you more equations just to make it so you can't just kind of guess a 50-50. Actually, this one, we're going to do these equations solve this differential equation. So for each one of these, if we look at our differential equation, we have the first derivative and the second derivative. All right, so for all of these, we're going to have to find the first and second derivative. So the first one, that's going to be derivative of sine is cosine. It's going to be 8 cosine of 4x. Remember, we're going to do the chain rule with that 4x on the inside. And the second derivative is going to be, let's see, negative sine. 8 times 4 is 32. Is that right? 32. Oh, it's negative because it's going from cosine to negative sine. So that's our first equation. If I plug that into my differential equation, I'm going to get the second derivative minus 6 times the first derivative plus 8 times the original. And I want all of that to cancel out, and you can see even if the sine parts did cancel out, there'd still be this cosine left that's never going to be equal to 0. So right away, 1 is out. And now we want to do the same thing for the second one. So y prime is going to be 6 e to the 2x. Y double prime is going to be 12 e to the 2x. Just remembering the chain rule each time, that extra 2 factor you're going to get. And then we're going to have 12 e to the 2x minus 6 times 6 e to the 2x plus 8 times 3 e to the 2x. All right, so we have all these 3 e to the 2x's. We're going to have 12 of them. We have negative 36 of them. We're going to have positive 24 of them. And those are all going to cancel out, and we get 0. So this one is a solution. All right, and the third one, we do the same thing. Just remember that c is some constant, so we're going to get 4c e to the 4x. Y double prime is going to be 16c e to the 4x. Again, the constant stays, and then the chain rule gives me that extra copy of 4 each time. We're going to get 16c e to the 4x minus 6 times 4c to the 4x plus 8c e to the 4x. And again, we want all of that to cancel. Let's see, we're going to have 16c of these. We're going to have negative 24c's and positive 8c's, all with the e to the 4x. And then all of that is going to cancel out and give me 0. So this is also a solution. So both 2 and 3 are right, which means my final answer is D. Again, this one, just the AP version of just asking if something is a solution. That's not going to happen, so they just give you multiple things to check. All right, 7 is just like 5. All right, we have to find our, if we look at our differential equation, we have to find the second derivative to plug in. So we're going to have to find the second derivative first. And then there'll be some k that we'll have to figure out. Right, this is going to be negative 2 and 2x plus 4k e to the 4x. Okay, just remembering every single time you have this exponent on your exponential, you have to do the chain rule. That's going to be positive 4 e to the negative 2x plus 16k e to the 4x. All right, so that's our y prime and y double prime. Now we can plug all this into our differential equation. So y is the original. All right, minus the second derivative over 4. I'm just going to be a little lazy and not outright that, but if I divide this by 4, this 4 here is going to cancel. And this is going to turn into 4k. It works. All right, one thing is that there's this negative sign here, so you can think about this being in parentheses, which means this simplified thing should also be in parentheses. All right, so all that's to say is that this negative sign distributes, and this is going to turn into a negative 4k e to the 4x. That's probably the most likely mistake people will make doing this, is that when there's negatives in front of this, even though this has 2 parts to it, that negative sign here has to apply to both parts. All right, now I can combine these cancel. I have k minus 4k, so it's going to be negative 3k e to the 4x. And I want that to equal the right-hand side, 5 e to the 4x. So I simplify the left-hand side. I want that to equal the right-hand side. I can cancel out the e parts. Negative 3k equals 5. Divide by negative 3 to get my answer of A. And lastly, we have the short answer question where we just have to verify that this equation is a solution. So if we want to do this, we look at our differential equation. There's a second derivative. So the first thing to do is figure out our second derivative. So y prime is going to be 4 cosine of 4x. Again, remembering because there's that 4x in the parentheses, you have to do the chain rule. Y double prime is going to be negative 16 sine of 4x. Now we take those and plug them into our equation. So 8y is 8 times sine of 4x minus y double prime is going to turn into plus 16 sine of 4x. All right, and combine those, you're going to get getting 32 sine of 4x. All right, and I think I must have made a mistake because this does not actually work out. So this, instead of negative 8, it should be 32. All right, so the one on the actual test will actually work out, but you have to show the steps. You can't just say, yes, it works out, because you know it's going to work out. All right, but this one you'd actually say it doesn't work out. All right, but the idea is the same. All right, on the actual test, you should show that you found the derivatives, show that you plugged them in, and show that this is the same as the right-hand side, or the two sides are equal to each other. All right, hopefully don't make a mistake and it actually works out.